is currently our cameraman.
Yep, I'm here too. Hi.
Essentially what we're doing here is we're investigating land ice versus sea ice melting.
Don't hold on to it yet.
And we had to make a little improvised platform here because we didn't have any clay for some reason. I thought we had clay, but we didn't.
Yeah.
But we've marked the level where the water starts. We're gonna put the ice cube in on the platform here because this is gonna represent the land ice, and just in the water, this is gonna represent the sea ice. I'm not sure why the instructions didn't tell us to put salt in there, but for the sea ice, that would make sense.
Yeah, that would.
Because salt lowers the
Yeah.
something does with the
The
ice.
melting point.
Yes, thank you. Yes, that's essentially what we're doing. We're gonna cover this kind of overnight and just see what happens. If it catches on fire, I know nothing about that.
No, we'll see how long does it take to
Right. Yeah.
and
so-
will the levels be different?
Also,
right?
Mr. Top's dog is here.
Okay, we'll
Yeah.
okay. So go ahead and put your ice on there now.
Technical difficulties.
About to say that.
All right. So
Oh, raise it quite a bit.
Yeah, it did.
And just put it on.
Nice is heavy.
just set it on top there. There you go. All right. So now, yeah, someone wants to mark again. Where the marker?
I don't have the marker. Where is the marker?
The mic.
Yeah, that's
Oh, you got it. Yeah, there you're good.
You can mark it if you want.
So mark it right at the new line, right at the new water line.
Should I put this back in the freezer?
Yeah.
Okay.
As I said, that's gonna melt.
What is this plant here?
That poor ice cube is melted.
Okay. So we'll come back every few hours or so, take a look at it, and then we'll also definitely check like at the end of the day to see where it's at, and maybe even into tomorrow to see where the levels are.
My hypothesis is that this is gonna rise faster because this is gonna rise slower because the ice in here is going to chill the water, which makes it so that it melts the ice less easy.
Okay. And I think it's also the overall. It's how fast is part of it, but mostly what we're looking for is how high, right? Because remember in the simulation we took a look at it,
Yes.
and they didn't include the sea ice in the simulation, only the land ice, and so it's like the question of does the sea ice make a difference at all? So that's why we're wanting to check it out. All right,
Yep.
so we'll see you later, Maddie.
Bye.
Bye.
Hi, Maddie. We're in math class currently, and we're just kind of measuring
Hello.
this because it's been a little over an hour. It's like 125 right here.
So what happened in the sea ice?
So the sea ice stayed the same, and I have a theory why.
Okay, hold on just a second. So it stayed the same. Let's just.
Yeah.
But what happened to the ice?
It's gone.
It all melted, right? What about the land ice?
Land ice
Went
is
up
still.
to like 125, and there's still some left.
Some ice left, but a lot of it's melted.
Yeah, a lot of it melted away.
Okay. So we'll come and check it again in a little bit. But you can, if you want to tell your theory of why, that's fine. But
My theory is that the rate of ice melting is the same rate as that water evaporates. So, like, if ice melts the same way that water evaporates. So, even if you have ice melting and adding water to this beaker, you have water evaporating and subtracting water from this beaker as well. So it kind of just stays the same.
okay, well, we'll see as we keep going. But that's a good test so far. We'll come back in about an hour and take a look and see where it's at then. Yep. Hey, Maddie, here's where it finished. So this is after school, actually. I just thought I'd finish it up and show you. So both are definitely melted. No more ice in either of them. And you can see the level of the water on the left. That was the sea ice, and it never changed. It stayed the same. You can see the level of the water on the right. That was from the land ice melting, and you can see they're both basically right at the same point. Sorry if it's blurry, but they're both right at the same point, same height. So the idea was, again, does the sea ice, like ice that's already in the ocean and if it melted, would it make a difference? The answer is no, because think of like when you drop an ice cube into water, you are, you know, the water level, like how we started off on that black line down there, the lower line on the left, and then it went up as soon as we put the ice in there. All right, so it started here and it went up to here as soon as we put the ice in. And that's just because water displaces when you put something like ice or a rock or whatever into it. And so with the ice in there to start with, the water level already went up. And then you can see it didn't change once it melted. So the answer of why we just don't even mess with accounting for the ice in the ocean already is because it's already accounted for. It's already taking up the space in the ocean, so it doesn't affect sea level rise at all. It already has affected it, I guess a long time ago when it first formed. So anyway, hope that helps answer that a little bit, and we'll talk to you soon. All right, bye, Maddie.